there should be no relationship between the two. Yet as they added each new point marking the speed of the stars against the mass of the black hole, a clear pattern started to emerge. To their amazement, the points lay in an obvious band across the graph. The properties were clearly related. The bigger the black hole, the faster the speed of the stars at the edge of the galaxy.
What we discovered is that the supermassive black holes at the center of galaxies and the galaxies themselves are really very tightly intertwined.
The stars at the edge of the galaxy have no physical connection with the black hole. Yet somehow their speed is tightly bound with the size of the black hole billions of miles away. If the two things aren't physically linked now, it means they must have been at some point in the past.
The fact that we see this such a tight relationship between the speed of the stars and the black hole in the middle is a probe to what happened early on in the galaxy.
It screams at you something that you don't yet understand about the connection between galaxy formation and black hole formation.
The relationship points at an extraordinary idea: that galaxies and their giant black holes could be linked from birth. In fact, scientists thought that supermassive black holes might even be involved in the formation of the galaxies themselves.
This correlation is the most important thing we've learned about supermassive black holes so far. Astronomers are always looking for correlations. Whenever you find one that's really tight like this one, it's a sign that there's some basic physics there that you need to look for.
As it happens, the physics that might explain what was going on had been suggested years before by theorists Martin Rees and Joe Silk. Joe Silk has spent much of his life trying to solve the mystery of galaxy formation. 3 years ago, it became clear that he'd been missing a vital ingredient. If there was a black hole in every galaxy, then scientists would need to explain what it was doing there.
We had to rethink our ideas of how galaxies were made. To understand the first light in the universe, we really have to include the role of these supermassive black holes in galaxy formation.
All previous ideas of galaxy formation had assumed that gas in the early universe simply condensed to form stars and galaxies. Silk and Rees came up with a completely different idea. They proposed that the center of each early gas cloud could have collapsed to form a giant black hole. The black hole would immediately start feeding on the gas around it, creating a brilliant quasar. Silk realized that the energy from this newly formed quasar would create intense temperature changes in the surrounding gas. This would cause the gas around the black hole and its newly formed quasar to condense into stars. Which means, in effect, that the black hole could have helped to trigger the birth of the galaxy.
We think of black holes normally as being destructive influences on their surroundings. In this case, they're creative. They're having a very positive impact on the formation of the galaxies.
But there was more. This theory predicted when and why the black hole would eventually stop feeding and go quiet. They calculated that this would happen when the feeding black hole grew so large that the vast amount of energy spewing from its bright quasar would literally force the rest of the galaxy out of its reach.
It has the effect of pushing in a wind against the surrounding gas and driving the surrounding gas away like a snowplow.
With only its hot, whirling quasar within its reach, the black hole would swallow that up and then stop feeding. It would be left invisible at the center of the galaxy. Silk and Rees calculated that this moment, when the black hole pushed the surrounding galaxy away, would depend, bizarrely, on how fast the stars in the outer galaxy were moving. The faster these stars were circling, the harder it would be to push them away. And the bigger the black hole would need to grow to produce enough energy to overcome the motion of the circling stars. Which means the size of the black hole in the end depends on how fast the stars are moving in the newly formed galaxy around it.
If our theory is correct, there should be a simple relation between the mass of the central black hole and the speed or the sigma of the stars in the newly formed surrounding galaxy.
And this is exactly what has just been found. It means that Silk and Rees's theory may be right. And if it is also right that supermassive black holes help trigger star formation, then it must mean that all giant black holes and their galaxies are connected from birth. It means the answer to the mystery of galaxy formation may lie in the creation of the supermassive black holes at their heart.
The real implication of the relation is that whatever controlled the formation of the galaxy and whatever controlled the formation of the supermassive black hole is basically the same thing. There is only one thing behind everything.
So a supermassive black hole, a force of terrible destruction, could also be fundamental in the creation of our galaxy. Nevertheless, its latent destructive power should not be underestimated. Back in Hawaii, Andrea Ghez has made a new discovery. She's discovered a new source of light in the center of our galaxy. The black hole may be starting to feed again.
All of a sudden we saw something that looks like a star, but maybe isn't a star, but it's definitely a new object in our map. And the interesting thing is that it's located where we think the black hole is.
Ghez thinks this spot of light could be something amazing.
One idea that I'm particularly intrigued by at the moment is the idea that perhaps the black hole is feeding more right now.
Andrea thinks that the light she sees is coming from hot gas being sucked into the vortex of the black hole. So, if our black hole has started feeding again, could this affect the Earth, even though we're 24,000 light years away?
We're in absolutely no danger of being eaten by the supermassive black hole. And in fact, if we do think the black hole is going through a slightly larger feeding at the moment, it's tiny. It's tiny compared to what other galaxies are doing. So in fact, still, this is a very quiet black hole in spite of the fact that there might be new emission from it. It's still extremely low.
Our black hole is merely having the equivalent of a small snack, feeding on a wisp of gas that strayed too close. The black hole stopped growing billions of years ago. Only a major catastrophe could make it fire up again. Something violent enough to hurl stars from the safety of our galaxy's edge into its deadly heart. And we now know that one day this catastrophe could happen. In January 2000, John Dubinsky set out to calculate the final fate of our galaxy, the Milky Way, and that of our nearest neighbor, Andromeda.
The Andromeda galaxy is actually falling towards the Milky Way, which means they'll probably have some close encounter at some point in the future.
At the moment, Andromeda is moving towards us at 400,000 kilometers per hour, and scientists think one day it will hit us. So Dubinsky decided to work out what will happen to us in 3 billion years when the two galaxies finally collide. After a long and complex calculation, the result was a vivid picture of the impending collision. A detailed prediction of how the Milky Way will end.
The clouds of gas hit each other at these huge velocities, hundreds of kilometers per second, and that basically creates great shock waves which move through the gas and heat it to great temperature.
At the heart of this maelstrom, the boiling gas is hurled towards the two converging black holes. This kickstarts a violent dual feeding frenzy as the two monsters spiral towards each other.
And eventually, those two independent black holes with their accretion disks will spiral together and merge themselves and form an even more massive black hole.
Dubinsky worked out that this violent collision would knock the Earth and its solar system out of orbit. Two possible fates await us. If we're on one side of the galaxy when this clash happens, we could be thrown out into the emptiness of space, if we're lucky.
The second possibility is that we're, say, on the other side of the galaxy at the time of the collision, in which case we could be thrown right into the center of this chaos.
In the active center of the merging galaxy, the huge feeding black hole will trigger giant stellar explosions and supernovae. This is bad news for Earth.
There could be a horrible catastrophe. The wave of radiation from the blast wave of the supernova would hit the atmosphere and boil it off in an instant. So the atmosphere would be gone, the seas would boil off into space, and the Earth would be toast.